So now in lesson 16A, in the next preview assignment in the next class, you're going to need to be able to interpret data presented in bar graphs and stacked column graphs, as well as calculate absolute and relative percentage changes. Let's start with bar graphs. You see the information in the following bar graph, and it is data from the United States Census Bureau on at-home workers in the United States. But let's look always. The age at-home workers, this is a percentage, it's going 0, 5, 10. And then we have 5 to 24, a range, another range of ages. And these are the ages of at-home workers. Question 1, if you haven't already done it, you need to stop and go ahead and look at question 1 by yourself and then come back and let's work through it together. Question 1 is talking about this graph. It says part A, how many bars are in the graph? And we have 1, 2, 3, 4, 5, 6 bars in the graph. Part B asks, what does the height of each bar represent? And the height of this bar is at 5, and that's percentage. So the height of each bar represents the percentage of workers in that age bracket who work at home. So in this case, 5% of at-home workers ages 15 to 24 are at home. Part C, how many bars represent at-home workers 44 years of age or younger? So here's 44, and 44 or younger. How many bars? 3 bars represent that age from 44 and below. Part D, does this graph show the total number of people between the ages of 15 to 24 who work at home? Why or why not? And if not, what additional data would be needed to compute this number? And it does not. This number tells us that 5% of all of the at-home workers, 5% of those are at home. Well, they're in ages 15 to 24 who are at home. So the total number of at-home workers is going to be needed to compute how many of these workers are between the ages of 15 to 24. Because if we knew the total number of at-home workers, we could take that number, multiply it by our 5%, and that would tell us the actual number of 15 to 24-year-old at-home workers. You're also going to need to know how to analyze stacked column graphs. The following graph shows the expected number of new cases of oral cavity and pharynx cancer in 2018. Here they are, the number of new cases, and the expected number of deaths from oral cavity and pharynx cancer in 2018. And here are the estimated deaths, separated by the specific location of the cancer. And so when you see this blue shade here, that's from here to here are the number of new cases, and from here to here are the estimated number of deaths from tongue cancer. It goes on to show mouth, pharynx, and other. So looking at question number 2, make sure you've already stopped to do it. It says in question number 2, in a stacked column graph, each column represents all of the instances, with each segment representing a specific type. What does the first column in the previous graph, the one we're looking at, illustrate? In that first column, it's the distribution of different types of new cases, expected cases of oral cavity and pharynx cancers in 2018. Part B, what does the second column illustrate? And the second column illustrates the distribution of the number of expected deaths from each type of oral cavity and pharynx cancer in 2018. So what does each color represent? Well, blue represents the percentage of tongue cancer cases. Orange represents the percentage of mouth cancer cases. Gray represents the percentage of pharynx cancer cases, and yellow represents the percentage of other oral cavity cancer causes. Part D. Which type of oral cavity and pharynx cancer is expected to have the greatest number of new cases in 2018? Well, to calculate that, it would be good for us to look at how many are in the blue. And it looks like aboutish 32% are in the blue, which are the tongue. This next one looks like it's about 58% is the highest on our orange. And then if we're saying that it's about 32, we can subtract these and get that this portion is about 26%. Moving on up here, this is probably about 93, 94. And if I counted this one as 58, if we subtract these, looks like we're getting about 36%. And then that would leave us with about 6% here. Before I answer this question, I'm going to go ahead and double check by adding my 6% to my 36% to my 26% to my 32%. And when I do, that adds up to be 100%. So now I'll answer the question. Part D. Which type of oral cavity and pharynx cancer is expected to have the greatest number of new cases? And since it's an approximation, we have about two. The tongue and the pharynx appear to be the most common because they have the larger segments. Which type of oral cavity and pharynx cancer is expected to lead in the most deaths in 2018? And how do you know? And I'd like to go ahead and do what we did a while ago, that this looks like about 25, and that would put us at 25% here. This looks like it's about 51, so that would put us at about 26% here. And if this is about 83%, we have 83% minus our about 51, and that gets us about 32%. And if we're treating this as 83, that would put us at about 17%. And I'd like to go ahead and add these up. That I have 17%, 32%, 26%, and 25%, and it does put us at 100%. Now I'll talk about Part E. It does look like pharynx cancer is likely to be the greatest cause of death because it does have the largest segment. So the last part of this lesson talks about changes in percentages. It mentions that we've already worked on some information like this in 7D. We calculated absolute change and we calculated relative change. These are worth looking back over to make sure you have these formulas memorized and ready to go. And this is going to be of the amount of money allocated by the government to education spending. Now we're going to review these. So go ahead, make sure you can write down these two formulas. And right here, we're starting with number 3. In 2013, 20,000, how about 2013, 80% of the original class of 2013 who started in 2009 graduated, lots of numbers. So 2013 had 80% graduate from Valley High School. And in 2014, 73% of the original class of 2014 graduated. 2013, 2013, 2014, 2014. Okay, what is the change in the graduation rate? You will recall that absolute change is ending number, which is our 73%, minus our beginning number. And what we're getting is a change of going down 7%. We had 80% in 2013, and then we're down to 73% in 2014. And this, we need to make sure that we write is, nope, I didn't write it right. We're going down 7 percentage points. I shouldn't have put the percentage. Because we're taking percent minus percent, we are going down percent, but it's not percent of where we started. It's an actual percentage points. Part B, so what's the relative change? Well, if we went down 7 percentage points, and the original number is 80%, I'm going to divide my 7 by my 80 and then multiply by 100. And I'm stressing the percentage points because we are not going to mess around with moving our decimal by dividing by 100. We're purely working with the percentage points, percentage page, wow, percentage points, purely the percentage points. When I divide and multiply by 100, I get 8.75, and now I officially can say we have a decrease in 8 7/75%. Remember that absolute change is a number, so we're going down 7 percentage points. But the relative change is an actual percent. We are going down 8 7/75%. Part C says, do you have enough data to determine the size of the graduating class of 2013? We know that it is 80% of the original class, but we don't know the actual number. So to know the actual number, we would need to know the number of the students in the class of 2013. If we knew that number, we can multiply it by 0.80 and we can get the actual size of the graduating class. But we don't have that information, so we cannot continue on to find that number. This completes our lesson 16A. You need to go check your syllabus to see if you have any more lessons to do for this week. If you do, keep going. If you don't, stop and then go do homework in another subject.